Good afternoon, ladies and gentlemen, members of staff of the University of the West Indies, and students. It gives me great pleasure to present my paper, co-authored by Dr. Roger Hussain, Reveal Comparative Advantage Persistence and the Dutch Disease in a Small Oil-Based Economy and the Associated Policy Implications. The objective of the paper was to explore persistence in revealed comparative advantage in Trinidad and Tobago over the period 1991 to 2008, to analyze the pattern of exports in Trinidad and Tobago, to explore how the Dutch disease syndrome has affected the pattern of exports, and to make associated policy recommendations. Just to define revealed comparative advantage. Revealed comparative advantage, or the concept, was pioneered by Balassa in 1965. Who suggested that comparative advantage could be revealed by observed trade patterns that reflect differences in factor endowments across nations. He also proposed to measure revealed comparative advantage through his Balassa Index, which today remains the most widely used index in the literature. What we did, we calculated revealed comparative advantage via the Balassa Index for every year 1991 to 2008. And we compared the average index from 91 to 93 to the average index from 2006 to 2008. Just a bit about the Balassa Index. The formula here is given. It is essentially a ratio of two ratios. The numerator is made up of the share of exports in a particular sector over total exports, while the denominator is the share of world exports of a particular commodity with total world exports. The Balassa Index has a number of advantages. However, there are some disadvantages. Most importantly, the asymmetric nature, because the Balassa Index ranges from 0 to infinity, where 0 to 1 indicates comparative disadvantages, 1 to infinity indicating comparative advantage. However, despite this disadvantage, it still continues to be used as the main index in the literature. Most recently, studies such as Bertanoi, 2009 used it to calculate intra-industry trade in Lithuania. Gregorovici in 2009 used it to analyze comparative advantage in Romania. And Georgiou in 2010 used it to analyze how government debt affects revealed comparative advantage. So it is the most widely used index in the literature. Just to give some idea of the state of comparative advantage. Revealed comparative advantage. Hinloopen and Van Meyerek developed this table which gives the different states. Basically, a score of 0 to 1 indicates industries with a comparative disadvantage. 1 to 2, industries with weak comparative advantage. 2 to 4, industries with medium comparative advantage. And greater than 4, industries with strong comparative advantage. We will use this classifications later on when we do our transition probability matrices and our Markov chains. So we calculated the number of industries with revealed comparative advantage from 1991 to 2008. And we can see the pattern being that towards 2000 onwards, there has been a reduction in the number of industries that demonstrate revealed comparative advantage. Just a bit about the theory, we expect that industries with comparative advantage, while we go forward in time, will either move to a situation of strong comparative advantage or a situation of comparative disadvantage. And when we plot the average scores of RCA in 91 to 93 compared to the RCA score in 2006-2008, we can see that there seems to be a bunching of comparative advantage across the main areas of trade, which is the energy sector in Trinidad and Tobago. Now, one must be careful when they're making decisions based on visual inspection. So we need to do further analysis to analyze whether the pattern of RCA has really changed over the period. I present some statistical attributes about the two distributions. We see that the mean of both distributions is fairly high, 0.66 and 0.62 for the two periods. Now, at first glance, it would appear that industries are very close to having a comparative advantage. However, the distribution is characterized by a high degree of skewness. As we can see, 655 for 91-93, 6.79 for 2006-2008. Chu 1990 and De Benedictis and Tambury argued that a distribution is characterized by a high degree of skewness, that the mean is not a good indicator of comparative advantage. Rather, you should look at the median. And we can see that the median for both periods are very low, 0.02 for 91 to 93 and 0.01 for 2006-2008. Therefore, we can say that almost half the sectors in Trinidad and Tobago for 91 to 93 and 2006-2008 has a revealed comparative advantage score of less than 0.02 and 0.01. Also, the Jacques-Berat test allows us to reject the null of normality, so we can conclude that both distributions are abnormally distributed. To help analyze the pattern of mobility, we utilize the Galtonian regression. A Galtonian regression basically states that the RCA in time period 2, in this case 2006-2008, as the dependent variable, and the RCA distribution in period 1, 91 to 93, as the independent variable. And we make our conclusions based on the value of the coefficient beta. If beta is equal to 1, there's no change in degree of specialization. If beta is greater than 1, the economy has become more specialized. If beta is less than 1 or greater than 0, there is no change in the specialization pattern. If beta is less than 0, then there has been a sharp reversal in comparative advantage. These are the results of our Galtonian regression. We can see the coefficient is 1.23, which would suggest that there has been a change or a mobility in comparative advantage. Just to analyze some of the other statistics, the R squared is high, the coefficient is significant, and the overall regression is significant. So we need to ask ourselves, is 1.3 significantly different from 1? To analyze this, we conducted a wall test, and based on the results of the wall test, we can reject the null that beta is equal to 1. So we can conclude that 1.23 is different from 1. So we can say that there has been mobility in the pattern of comparative advantage. To analyze further, we utilized Markov chains and transition probability matrices. A Markov chain may be defined as a sequence of random variables whose probability values at time period t hinge on the value of a number in time interval t minus 1. And a transition probability matrix is defined as a square array of non-negative numbers such that the rows tally to unity and represent a discrete Markov chain. This was our constructed transition probability matrix. We would notice that the first diagonal element, which is A to A, which basically states that industries that has a score in class A, which is a comparative disadvantage, has a high probability of remaining in a comparative disadvantage in the second period. Also, if we look at the last diagonal element, which is state D to state D, we can conclude that an industry with a strong comparative advantage has a high probability of remaining in a strong comparative advantage class in the second period. However, if we look at the second and the third diagonal elements, we see that the probability is very low, in that industries with a weak comparative advantage has a strong probability of having a comparative disadvantage in the second period, whereas industries with a medium comparative advantage has a strong probability of becoming a comparative disadvantage in the second period. We will now analyze for the presence of Dutch disease. Now, Dutch disease is a phenomenon that originated in the Netherlands. Basically, when a country has rich resource endowments and exports a lot of energy, the result would be upward pressure on the real effective exchange rate. And that would effectively squeeze out exports of manufacturing and basically the non-energy sector. So to analyze the presence of Dutch disease, we have a scatter plot which basically plots the real effective exchange rate in Trinidad and Tobago against real oil prices. And we see that there's an upward trend, indicating that real oil prices has an upward effect on the real effective exchange rate. We then plot the real effective exchange rate against RCA, the number of industries with a revealed comparative advantage, and we see that there's an inverse relationship. When the real effective exchange rate goes up, the areas of revealed comparative advantage goes down, which seems to suggest the presence of the Dutch disease phenomenon. We further analyze using mobility indices. A mobility index attempts to reduce information about mobility from a transition probability matrix into one single statistic. There are basically 4 mobility indices in the literature. The Shorrock's Index, which analyzes the trace of the matrix. The trace is the sum of the diagonal elements. The Bartholomew Index, which looks at the ergodiac distribution. The Shorrock's Index, second index, looks at the determinant, and the Summers and Const Index looks at the eigenvalues. We utilized M4, which is the Summers and Clunk's Index, based on its popularity in literature. And we can see that there has been an increase in mobility over the period 91 to 2008. We calculated the index every year from 91 to 92, 91 to 93, 91 to 94, and so on. And if you notice, 91 to 95, 91 to 05, 91 to 06, 91 to 07, and 91 to 08 shows a high level of mobility according to the index. Just to further analyze the presence of Dutch disease, this graph shows the real effective exchange rate against the share of agricultural exports. This is SITC 0 and SITC 1. And we can see as the real effective exchange rate appreciates, the share of agricultural export decreases significantly. We calculated the correlation between the two distributions, and we found it to be negative 0.68. Also comparing the real effective exchange rate against manufacturing sector exports, this is narrow manufacturing, SITC 7 and 8, we can see the real effective exchange rate going up and manufacturing sector exports going down as well. And the correlation, the index of correlation being negative 0.38. So we need to find out whether the Dutch disease exists, whether real oil prices causes a change in the change in comparative advantage. So we ran a series of Granger causality tests. The first test tests whether real oil prices change the number of industries with a revealed comparative advantage. And we can reject the null that real oil prices do not Granger cause RCA in industries. So we can conclude that real oil prices has a causal effect on the change in RCA industries, and it's a one-way causality. Test 2, we test whether the real effective exchange rate has an effect on the mobility index. And we can reject the null and conclude that mobility indices has a causal relationship on the real effective exchange rate. So as the pattern of export changes, that affects the real effective exchange rate in Trinidad and Tobago. And finally, we tested whether the number of industries with RCA, that has an RCA score greater than 1, whether it has an effect on the mobility index. And we can conclude that the number of industries with an RCA score greater than 1 has a causal effect on the mobility index, which makes sense in that as you change your pattern of exports, as the number of industries with comparative advantage changes, it would have an effect on your mobility index. So some conclusions and some recommendations. We can conclude that there's a shift in the pattern of specialization from the period 91 to 93 to 2006 to 2008. Industries with a weak comparative advantage have a high probability of moving towards being in a position of a high comparative disadvantage. This shows that there's a mobility in the pattern of trade. We also concluded that the Dutch disease phenomena is very present in Trinidad and Tobago for the period 1991 to 2008. Some recommendations. The government should enact further policies to promote diversification of the economy so as to ensure that there's greater persistence in comparative advantage. They also need to put in place policies that promote competitiveness in the manufacturing and services sector so as to increase the value added within these sectors. We also recommend that there's continued development of the human capital in the country through the GATE program. We recommend a more efficient GATE program, and to create a culture of innovation and research and development among businesses in Trinidad and Tobago. That's it. Thank you very much.